Yeah. Okay. Let's go then. Thank you very much for this opportunity to present in this very interesting event. So indeed, I come from VTT, and VTT is a multidisciplinary research organization, and also the sustainability of electronics. We have tackled this issue also in a very multidisciplinary way. So we are collaborating at VTT between the experts of flexible electronics, the people working with the development of bio-based renewable materials, and also people who are experts in circular economy. And I think that this is the challenge is very multidisciplinary. So we also need tools which are very multidisciplinary. And I guess I don't need to speak more about the motivation why this is important, because this was already presented very nicely by David. So indeed we are piling the electronic waste around us. That's an issue, and also the issue is that we are using the materials in such a speed that at some point we will run out of some valuable materials which are used in manufacturing of electronics. So definitely something needs to be done to these issues. So basically, we have been thinking that we can classify or categorize the tools for sustainable electronics manufacturing into 3 categories. So first we can think about the design, the eco-design, so that the design is really making it easier to recycle, reuse, and repair. Then, as we already have heard in the previous talks, the manufacturing method as such is very, very important, and you need to pay attention to the energy and material efficiency. And then the wise selection of materials is also in a key role. And in the next slides, I will open these 3 themes a little bit more detailed. So first, I would like to talk a little bit about this design aspect, the eco-design. So there, I think the key is to pay attention to design in such a way that it is indeed making the reusability and recyclability easier, because it's always more efficient that the more you can reuse, or the more you can really recycle the already produced elements and components. It is more efficient from the sustainability point of view. And what is important here is that we are designing electronic products which are, for instance, based on modular structures, so that it is easy to disassemble or disintegrate the products at the end of the kind of the shelf life, so that we can maybe partially reuse them, and that part of the products, it's easy to, for instance, dispose the products into certain waste streams, and that is not easy if you have very many different materials combined. So it's always a challenge. But related to design, I would really stress the importance of thinking about the end of life strategy, and like the post use of the product. So what happens to the product when it has been used in a purpose where it was made to? And a part of this design aspect and this recycle and reuse kind of plan is to create and develop new solutions for traceability and for product passports, and this can be used, for instance, to trace and track and trace valuable and rare raw materials, and also components which are containing these materials, so that they can be then really efficiently reused or recycled. So this is, I think, also something where we can use the tools which are kind of created in, for instance, in printed electronics to label the products, not just products of flexible electronics, but other products as well. Then shortly about the manufacturing methods. So we already heard in the previous talks about the about printing, how it is more energy efficient, but also in many ways it is also material efficient way. And in a study which was carried out by our collaborators in Lappeenranta University of Technology, in a VTT-led electronics national project, it was found out that, for instance, if you're able to use printing instead of conventional electronics manufacturing methods, it's possible to reduce the global warming potential to 14% only, which is really nice result. And the link to this paper is here in the corner of the slide, so you can check some details from there. And related to the manufacturing, I also would like to mention that printing is nice in that way that it is quite nicely and easily compatible with several renewable substrates where the temperature tolerance might often be the issue related to the substrate. So not always you need to go into very high temperatures. So that is good. And also from the sustainability point of view, the occupational health and safety is one aspect to consider, and quite often it's possible to use mild solvents when you work with printing-based manufacturing methods, so which is also a benefit. And in the picture here is an example from a device fabricated on paper-based substrate. It is an anti-counterfeit tag, and it's produced in a reel-to-reel printing process, and in this process more than 10 layers are printed in a register. So very nice result, and indeed a paper-based concept here. And then last but not least, I would like to talk about the material selections a little bit. So we can think about the materials as substrates, but also as active materials. And one aspect in this field is to replace and try to shift from fossil-based materials as substrates to substrates which are originating from renewable resources, for instance, wood-based or cellulose-based materials. We have, for instance, been working with different cellulose-based films, and sometimes with this can even be biodegradable or compostable. But also you need to think about that: is it kind of essential from the use case point of view? Sometimes it is so that, for instance, in the case of medical devices, the components are the waste is treated by incineration, and then it is not necessary to have a biodegradable material there. But the origin of the raw material is also important, and always you would need to consider the whole life cycle of the product. And related to substrates, I would also like to mention that we often think that when we replace the conventional fossil-based foils with the bio-based foils, we somehow compromise with the performance. But it doesn't always need to be so. That sometimes you can get, for instance, a better adhesion on a bio-based substrate, or you can maybe even introduce some new functionalities which are only enabled by the material selection. For instance, we have created some cellulose-based optical structures at VTT. And related to material selections, I also would like to mention the conducting materials, especially silver has been found to have some not so nice environmental impacts, and always when possible it is good to consider like possible options. Of course, in that case it is often like a compromise in the performance, but if possible, then this is also something to consider and investigate. And also related to materials, the powering solutions, they are very important. And we are, for instance, currently looking at powering based on new renewable materials. For instance, biocarbons can be used in energy storage and energy harvesting products. And in this photo here is an example of an energy autonomous label, which is based on bio-based substrates, and it contains a printed solar cell in the tank, and that is producing the energy to a temperature sensor, which is hybrid integrated to the printed circuit. So all in all, we can say that there are very many tools to tackle the sustainability issues, and this is a very multidisciplinary challenge, and we have been working a lot in this front already in several projects, and the work is very much going on still. And I would really like to thank all my colleagues at VTT and also the collaborators, and of course I would like to thank you for your attention. Thanks.